Number 7 is an interesting identity, and here's why. Let's say you grabbed your unit circle. So let me just explain to you what this identity is trying to show. Okay, so we're going to go ahead, grab our circle. There we go. That's not too bad if I say so myself. Now, let's pick an arbitrary angle. I'm going to call it theta. So here's theta. What this identity says is, okay, look, if you add 90 degrees to theta, so basically I'm going to make a right angle on this guy, so I'm going to add 90. There it is. So this yellow angle is theta plus 90. And then if you subtract 90 from it, so subtract 90, so that this angle here in the blue is theta minus 90 degrees. Put a little degree symbol up here. That these two angles, if you take their cosine values and add them, so if you add the cosine values of those two guys, you'll get 0. And if you just look at this drawing, that's got to be true. Because think about it. This length, I'll do it in red. This length right here is the cosine of theta plus 90. So that length is the cosine of theta plus 90 degrees. And this one in orange is, that length right here is the cosine of theta minus 90 degrees. And if you added the red, which should be a negative value, and the green, or excuse me, and the yellow, which is a positive value, and they're the same lengths but opposite directions, you should get 0. So like maybe this is negative 0.5 and this is positive 0.5. So you should get this value of 0 out. So that's what this identity is saying. Now, instead of proving it out graphically like we just did, we're going to prove it out algebraically. So we're going to prove it as an identity. So obviously, we're going to work with the left side here. Okay, and I'm going to use my sum or difference formulas because I've got sums going on and differences going on inside my trig functions. So this is going to be the following. It's going to be the cosine of theta times the cosine at 90 degrees minus sine theta sine 90 plus, okay, so this is just the first one. Okay, the second one is going to be, let's see here, cosine theta sine 90 plus, oh, that's not right, cosine 90. Plus sine theta sine 90, like that. So let's see here. I've got a sine theta sine 90 that's negative, and then I have a sine theta sine 90 that's positive. So let's get rid of those two guys. Now we've got cosine of theta times 90 degrees. Well, the cosine at 90 is 0. So this guy is cosine theta times 0 plus, same thing over here, cosine theta times 0. So this guy is 0, this guy is 0, and you end up with just 0. Pretty cool identity though, if you think about the way this is set up and the geometric version of it, I think is pretty interesting to look at.